You come late, but nothing told yet. We haven't started yet. So this question, do you still remember? We have done this one before. So we have to do it using the quadratic function, and this time we try to use the relative motion to solve it. Okay. Now, in this case, both the two boats, the two ships are moving. It will be always very annoying if two objects are moving instead of one. But if you are using the relative motion, then we can change the motion of the two objects into the motion of one object only. So in the solution, okay, we say relative to B. So that means it set the B to be the observer of the motion. If B is the observer, then in the reference frame of B is at rest, and only A is moving relative to B. In that case, so we need to okay, so you just consider B as the origin of the coordinate, and B is at rest, and you're going to find the relative. I think in the solution is mess it up. Is it? Oh, hmm? Oh, okay, okay. So this is a solution given by my student, okay? But they give you the same answer. But let's see, have a look, okay? If we consider the frame of ship A. So that means uh consider that A is at west and B moves relative to A. Then in this case, you will consider that find the relative velocity of B relative to A. Now we have written down a formula on last lesson, and let's see if we can get something more interesting. Just a second. So let's see if we can get more interesting. Sorry. Uh, so how let's see how we apply the formula. So there's two objects only. It seems that there's only two objects, ship A and ship B. So do you still remember we have the formula with the three object A, B, C? But in this case, the ground is the another object. Okay. So let's say if you write down the formula, it will be like VAG. No matter, okay, I didn't need to look at the formula. Okay, so VAG is equal to VAB plus VBG. Okay, I just write it very naturally and very quickly. So you just see AG equal to AB plus BG. Right. So AG is the velocity of A relative to ground. So that is the up. Sorry, that is the upwards 5. And VAB is the relative velocity that we want to find, but this is the velocity of A relative to B. But if you want to find the velocity of B relative to A, it will just be the minus velocity of A relative to B. And then VBG is uh, uh, the velocity of 12 to the right. Okay. So let's say if you want to get VBA, velocity of B relative to A, so it can be written as VBG minus VAG. I hope you can write this one directly. Okay, directly. You can consider BG minus AG as BG plus GA that give you BA. And now I think the concept behind is not that difficult to understand. So let's say the velocity of B relative to A is just the velocity of B minus the velocity of A. Then you can get the velocity of B relative to A. So VBG is to the right 12. VAG is upwards 5. Okay, you just do the subtraction of these two vectors. So 12 And then do you still remember when you do subtraction? That means you do addition, but in the opposite direction, 12 and 5, like this. Okay. So and but we don't know whether this relative velocity is in this region or in this region. Do you know what I mean? You can just calculate the angle. Okay, just calculate the angle. So the angle theta here. Okay, the angle theta here. You know how to calculate an angle theta. So tangent theta is just 25 divided by 120. And let's say if this angle is alpha, okay, this angle is alpha. So tangent alpha, tangent alpha is 5 over 12 because this n is the relative velocity, the velocity, the angle velocity, angle of the relative velocity to the horizontal. So 5 over 12, and then just calculate the angle to see which one is larger, and then you just draw corresponding diagram. But in this case, we know that okay, the alpha is larger than the theta. Then the diagram look like this one. Okay, so and then how does the ship B move relative to A? Like in the frame of A, then we consider ship A is at rest, and the ship B move relative to A. So and then you see there's no acceleration. So that means ship B actually moves with constant velocity relative to A. Constant velocity, that means it's moving at constant speed on a straight line. So you just just extend this one. Okay, so this is the path of B relative to A. And if you want to find the minimum distance between A and B, then I think it's not too difficult. It's just looks like a straight line and a point, and find the shortest distance, and it will be the perpendicular distance. Okay, perpendicular distance. Then to find this perpendicular distance, okay, we are always using trigonometry to solve to find the distance. So then you need to have a look at which right angle triangle we can form. I think obviously it's this one, is it? This is the right angle triangle that you're going to form, and then you are going to find this side, and this side this is the hypotenuse of this right angle triangle is the just using by using the Pythagoras theorem you can find the hypotenuse, and then for this angle, okay, this angle is what I call is alpha minus theta, okay, and he labeled as phi. Then you just alpha minus theta and equal to phi. And then just by using the trigonometry, you can solve the distance. Okay, then you get the same answer as what we have got before. So it's 23.1 meter. I think the concept behind is not that difficult, but uh, the most annoying thing is the mathematics behind. Do you have any question about this one? If no question, then let's move on. Yeah. So in this question, now, I will say it like this, okay? We'll deal with some of the few of the question. So okay, we are dealing with the relative motion of two objects with constant velocity. So both of them are moving at constant velocity. That means the angle does not change during the motion. The direction, the speed does not change. So in this case, A B, okay, uh, uh, you know for the vector there's two. It contains the magnitude and also the direction. In this case, both magnitude and directions of both velocities are known. But the next question, okay, you have a look at the question first. So there's a lion is chasing the deer. So the deer and the lion, the magnitude and direction. So we know the magnitude and the direction of the velocity of deer, but we know the magnitude. Sorry, we don't know about the magnitude of the line speed velocity and the direction of the line velocity. But we want to find the minimum velocity of the line. Okay, but we just want to solve this one. Right. So, first of all, I think is first of all there are four arrows right here. So let me label as A, B, C, and D. Okay. So let you think about it. To make so the lion want to be lazy. Okay, you don't want to chase the deer at a high speed. So in which direction should the lion moves? So you choose the answer. A, B, C, or D. C is towards M. Actually, A and B are the same thing. It just means northeast direction. So that's three choices given to you. Okay, either north, that's C, northeast, that means D, and northwest means A or B. Don't look at the solution. Okay. So in which direction should the lion move such that it can chase the deer with the small speed? Okay, two of you choose D for dog, and one of you choose C. A C could be an answer if the distance have some relation behind. It can be a answer, but not always. Is it? Oh no, no. Sorry, the answer must be D. The reason behind is like that. Okay, I think you won't choose A or B because if for A or B, that means it travel for a short. It meet the deer in a shorter time. Is it shorter time? So let's say if you travel the distance, okay, let's say this distance is 120, and this distance is also 120. So let's say this point is point A and point B. Let's say these 2 point, the lion can also catch up the deer. So you, of course, you think that okay, A, uh, A takes shorter time. That means the speed should be larger. Okay, so that means you won't choose this path. What the only path you choose is either C or D. And then compare C or D. D can take a uh, longer path. Sorry, it takes a longer time for a deer to reach this point, such that the line can use a small speed. But you may argue that okay, compare C to D. D takes a longer distance than C. Okay, so you know a speed is distance over time. So D takes a longer distance, but it takes a larger. It takes a longer time. So actually, we need to calculate to see whether the answer is C or D. You know, uh, both numerator and the denominator is larger. If you can't tell whether the this fraction, the V, is smaller or larger. So then we need to do some analysis. We have done some basic analysis. Then let's go on to have a look at how we can solve this question. So now in this case also, okay, so this is the motion of two objects. And also if we are using the relative motion, then we can simplify the question by just consider the motion of one object only. Okay, one object only. So let's say in the lion's frame, so in the maybe let me use another frame. Okay, so in deer's frame, okay, in deer frame. So in deer's frame, the lion does not, sorry, in it itself does not move. Okay, the deer does not move. Only the lions moves. Okay. Uh, and then if the lion can chase the deer, the relative velocity of the lion relative to deer must point towards deer. I hope you, I think you agree with it. If not point towards the deer, because now you know that both velocities have this certain direction. That means that the constant magnitude and constant direction. Then the relative velocity also have the constant magnitude and constant direction. So that means the line is actually moving along a straight line. If the initial velocity or the relative velocity of line relative to the deer does not point towards the deer, then the lion cannot chase the deer. So that is the idea behind. So the velocity of lion relative to deer is the velocity of lion minus the velocity of deer. Okay. You can say the velocity of lion that is the velocity of lion relative to the ground. I hope you right now can write down this formula quickly. Then because we know about the magnitude of we know this one, but know nothing about this one. We know the direction of this one, but we don't know about the magnitude of this one. Okay. So if you want to draw the vector diagram, so how can I draw it? So I will first draw this one, is it? So minus VD, then it will be point towards to the right, so to the left. And then plus VL, okay? And then that gives you the velocity, that is VLD. Now, VLD may not be this vector. It can be longer, it can be shorter, because we don't know about the magnitude. But we know that it must point, it must be along this direction. And then such that the VL can have different direction and magnitude. So let's say if I use different color of pen. So let's say this, okay, let's say the VLD is this green arrow. Then the VL should be the vector point towards here, is it? Such that the VL plus negative VD is in this direction. Okay. So let's say if there's another, uh, let's say if this one, okay, this one, this is the VLD, then the VL must point towards here, such that the sum of the VL and negative VD point towards this direction. Okay. But if you compare the the green one and the blue one, you see that okay, I think obviously the green one is shorter. But how can we make the VL be minimum? The trick is quite similar to the last question. So the trick is like this, okay? So this is a point. So this is a line. Actually, you're all you uh you're also finding the shorter distance from between a point and a line. So this one should be a right angle. Okay, this one is a right angle. So then we know this magnitude. Okay, so that means we need to know this angle, and then we can solve the VL. So this angle theta is actually the theta here that I indicate on the diagram. Parallel axis, sorry, this is what it's called. Alternate angle parallax, is it? Or corresponding angle parallax, I forgot all these reasons. The next step, and you find the tangent theta, find the angle theta. So tangent theta is 100 divided by 240, and then the VL will be VD times sine theta. And that's it. Then you solve the question already. Any question? I'll just stay here for 10 more seconds and then let's move on. Okay, so let's move on. This one is quite similar. Okay, it's no. This one is it actually easier. This question is easy. So you have a look at the question first. So it's ship A, a certain instance, the ship B is 20 kilometer due west of the ship. So in this case, okay, A and B, two objects, okay, also two objects. Then the magnitude, okay, we know this is 30. We know this is 15 square root 2. And the direction, this one is known, this one is unknown, okay. And we want to find the earliest possible time the ship B can reach the ship A. So this velocity is 30. So this velocity, we don't know point to where. So of course, it can't be, it can't point this towards this direction, is it? Otherwise, the time will not be shortest. So it must point something direction, something like this, is it? And so let's have a look at how to decompose a 30. So this is 30 cosine 30, 60 degree. So that means this is 15, and this is actually 15 square root 2, no, square 3. So why I need to decompose it like this, okay? Because if the speed of ship B is less than 15, then ship B can never uh, meet or reach the ship A. So because let's say when they reach the ship A, so that means they have the same x and y coordinate at the time. Because initially both A and B are along the x-axis, so both A and B have the y coordinate 0. So that means at that time when they meet, they both travel the same vertical displacement. Okay, I hope you understand what I mean. So let's say if A move upwards by 10 meter, then B should also move upwards by 10 meter, such that they have the same y coordinates. They travel the same vertical displacement. They travel with the same time. So that means they have the same y displacement. And divide by time, you should get the same uh, vertical velocity, is it? They should have the same vertical velocity. Actually, when I do this question, I'm not using this method to do it. I'm using this logical thinking. So, okay. So A has a velocity, vertical velocity 15, and horizontal is 15 square 3. So B should have the vertical velocity 15, such that they can travel the same vertical displacement. So, and then the velocity is 15 square 2, so that should be a horizontal component. So can you tell me what is the magnitude of the horizontal component in this case? You type me in the chat. I think you know how to calculate. I don't think you should use your calculator. Done. You get the answer. Yeah, the answer is 15. Because let's say for a isosceles right angle triangle, the side is 1, 1, another is square root 2, is it? So this one, the The hypotenuse 15 square root 2. So that means another side, this one should be 15. Okay, ignore the solution. Can you get the answer? Okay, I give you all the hints here already. So can you get the answer? Do you know how to do it? If you know, can you write me some step to find the final answer? Find the shortest time possible. We just consider horizontal motion. So initially they are 20 kilometer apart each other. Then one has a speed 15, one has a speed 15 square 3. Okay. So the relative velocity in the horizontal direction is 15 plus 15 square 3. So you just add these two together and then 20 divided by by the relative velocity. Then you can get the time. Okay. Somehow we still use the concept of the independence of the horizontal and vertical motion in this question. And yeah, and somehow this method is, I think, is simpler than than this solution and more trivial. Mhm. Okay, then I think I get the answer C. Then maybe let's have a look at the next one. So this is about the water flow and the ship. If you still remember, actually we have done this question before already, but in this case, the swimming speed is larger than the water flow speed. Right? But in this question, okay, in this question, the water flow speed is larger than the speed of the ship. You look at the English, okay, don't look at the Chinese. I'm not sure if you understand the question or not. So there's a river. So the water flow at the speed 4 kilometer per hour, and then the ship, it wants to travel with the, if it can travel vertically, okay, vertically, then uh, then the downstream displacement will be zero. But in this case, it can't, because if it want to travel, I think, sorry, I pressed the wrong button. In this case, if it want to travel uh, vertical upwards, like what I say with zero downstream displacement, then it need to have the speed larger than 4, such that it can form a uh, the when you do these two addition, okay, then the resultant vectors can point upwards. So this, of course, this one should be larger than this one. If we can see 4.000.1 is still fine, because your triangle will be very thin, not like this one. Okay, it still can move vertically upwards. But in this case, the speed is less than 4. So then it can't move like that. So then how we can do it? So in this question, okay, there's a boat and also the water. So both magnitude are known. We know the direction of the waterfall, but we don't know about the direction of the boat, and also we want to find this one. So how can we make it to be smallest? So you know the speed of the boat relative to the ground or relative to the earth, you just do the addition of these two vectors. So then, because this is a known vector, this is a known vector. So we draw this one first, 4, okay? But this one, we don't know the direction, but we know about the magnitude. So how can we do it? So actually, you can draw a circle with the radius 3. So that means it can point towards here, this here, towards here, towards here, towards here, towards here, and towards here. And then, if you want to find the resultant of, to see which resultant will give you the smallest downstream displacement, then we are looking at the relative, sorry, not the addition of these two velocities. So that means it can be, okay, if the vector is this one, and the resultant will be this one, the resultant will be this one, the resultant will be this one. So let me draw you with two colors, two different colors. So let's say the green one here, okay, the green one here, and then the blue one here. So which one will have a smallest downstream displacement? Of course, the answer should be the green one. The green one. So because when you extend this one line, and then let's say this is a river, and then the blue one will have a larger downstream displacement than than the green one. Then how can we determine which direction will give you the smallest downstream displacement? So let me draw the diagram again. So this is a straight line with a circle here. Oh, sorry, my poor drawing. So there are many possible directions, but the one with the smallest downstream displacement should be the one that has a larger angle here. Okay, it has the largest angle with the horizontal. Then which one will be larger? This is the one that is the tangent of the circle. So this angle should be right angle. Okay? This angle should be right angle. This angle, such that it is tangent here. So in this case, to find this angle, okay, I think you are going to find this angle, this angle. Then you use cosine theta, just 304. Then you can get the answer that is, I think it's d for dot, is it? Is it d for dot? Oh, no, 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 sorry. It's c for cat. Yeah, sorry. C for cat. Okay? I think it's almost the end for this topic now, okay? Yeah, okay. This one also need the concept of the momentum and also the energy. Okay, we finished this topic already. Yeah, so happy. And then, so for the kinematics, that is a study of the motion. We finished a 1D, 2D relative motion. We still have circular motion, but I will skip this part first. And also, constrained motion. We'll talk about the constrained motion in the topic of force because I want to teach a bit faster. Right now it's too slow, a bit slow. And then, so from next lesson, we are going to talk about the forces. Okay. Then, if you have no other questions, you can skip those exercise behind. They're too complicated. If you have no question no any other question, then let's meet on Saturday morning. Is it? So let's meet on Saturday morning. Okay.